We acknowledge the first Australians as the traditional custodians of the continent, whose culture is the oldest living culture in human history. We pay our respects to elders, past, present and emerging, and we respect their cultural heritage, beliefs and relationship with the land. We extend our respect to all Aboriginal and Torres Strait Islander people here today. They share the memories, traditions and hopes of the traditional ancestors with the new generations today and in the future. We would also like to thank them for looking after this land for thousands of years.
Good afternoon, everyone, and welcome to SciFest Day 5. It's been an exciting journey of science, and we're very excited to have everyone here again with us today. And a big thank you, of course, to National Science Week and the Australian Government for supporting these programs, both for SciFest and across all organisations for National Science Week. So we're going to hand over to Street Science. The team from Street Science are going to be delivering our fabulous program for today. So welcome everyone and enjoy the...
Good afternoon, everybody. Who's excited? It's National Science Week, Australia's celebration of all things science. Now, I know I'm super excited to get this show underway, but first, I want to know, whereabouts are you tuning in from? Because I know there's a lot of people all around Australia, so in the comments, let me know. Tell me, are you coming from a city, a town? Where are you coming from? Now, this year's show is all about the National Science Week school theme of innovation. Now, innovation being creating something new, either a new method, a new tool, or a new product. And just thinking about what we're doing right now, coming to you live in your own house, that's an innovation that we didn't have only 20 years ago. So I'm seeing people are coming in through the different comments. That's how we go. We got Bonnie Reed Heights Primary School, Kangaroo Islands, South Australia, Canberra. Oh, we got lots of people from South Australia, Stanmore in New South Wales. Woo! I think we're going to have a good show today. So let's kick things off. But it's not going to be me doing the show today. It's going to be one of our most amazing, most exciting, most energetic presenters we have here at Street Science. So I want everyone to give us some like cool little clappy hands. I'm seeing you through the camera. Get some noise, scream at the top of your lungs. Please welcome Dr. Shaz, our Street Science presenter.
Woo! Hi guys, I hope you are having a fantastic day so far. Happy National Science Week. Today we're here to talk about innovations, and one of the probably the most greatest advancements of human history was the mastering of fire, right? Now, fire, when we first was able to master it, gave us the ability to cook food. It gave us the ability to be warm, to have protection, especially at night. Now, these days, we use fire to generate electricity or power, which powers our homes, our computers, everything that we use on a daily basis. Now, the way we do this is that we use the heat energy generated from the fire to boil water. That water then creates something called kinetic energy, and the steam, being able to move really fast. That steam spins a massive turbine, which can then be used to create the 3 M's. Movement, magnets, and metals. And those 3 M's can be used to create electricity. Now, today, I want to try and stimulate that, but I don't have a massive turbine. I don't have steam. So instead, I'm going to use this guy here. This is a thermoelectric generator. It works by using a heat sink or a heat differential. If the bottom layer gets really, really hot and the top layer stays nice and cold, we should be able to get those electrons to flow. So let's move my Bunsen burner closer. As those electrons start flowing, they're going to be moved through my thermoelectric generator, moving through the wires to my propeller here. And if we can get that energy going, we should be able to get that propeller to spin. All right, so let's get this going. I've got the nice blue flame on, so it's going to get really, really hot really quickly. That fire heating up, that heat different. Oh, there it goes. It's starting. It's starting. We're getting a little bit of energy. We need enough to get it to go, though. And almost. There it is. We have it spinning. We have been able to get electricity, the flow of electrons from our Bunsen burner, from heat. How easy, right? Now, like I said before, in order to get electricity, the flow of electrons, we just need a turbine to spin. We can use heat energy for that, but there are other ways that we can get kinetic energy. And one of those ways is using a little bit of pedal power. And I want to bring that up right now. Over to the side here, I've got a bicycle, right? Now, a bicycle works kind of similarly. If I start pedaling my bike, I can get kinetic energy, the movement energy, right? Now, this particular bike's been rigged up very specially. It's got a motor and a generator right here. So as I spin the pedals, I'll be able to get my electrons flowing. They're going to get that motor pumping, and it's going to send that electricity all the way through these wires till it gets to this light here. So if we can get it going, we should get the light going. Fingers crossed, let's get some pedal power. Oh, there we are. Amazing. The moment I start pedaling, I get electricity flowing. How crazy. Now, this is a really cool concept. In fact, there are some researchers from MIT in Copenhagen who managed to get this to work. They put a pedal power, attached it to a battery. So as the person pedaled the bike, the battery charged. And that battery was then attached to the wheel of the bicycle, making the first self-propelling electrical bike. So a bike that was able to power itself. Amazing, right? The only problem with this is you're probably not going to be able to generate enough power to power your home, your TV, your fridge, just by pedaling a bike. So we need other ways to be able to do this. Using heat is a good way because you can burn lots of things to generate that heat energy to get your electricity. But the problem with doing all of that is that we also release carbon dioxide into our atmosphere. So most of the time when we burn fossil fuels, which is what we do here today, we actually release carbon dioxide and carbon molecules from the deep into the ground that have been stored away for millions of years into the atmosphere, which has some very devastating effects. So scientists are looking for more cleaner, sustainable and renewable ways to create that electricity. So different things that we can use to get that turbine to spin to get electricity. Now we can use things like hydropower. That's using the movement of water to spin that turbine. You can use things like biofuels, that's powering sugarcane or using sugarcane and other waste products to burn those to get the heat energy to boil the water. You can even use things like wind, which you may have seen massive wind turbines that look a little bit like big propellers that are sitting on the ground. Today, I think I want to have a go at using some renewable energy. So let's bring out my propeller again. Let's bring them back. I'm going to disconnect my heat sink, because we're not going to use that today, and bring out this little turbine that I've got here. How cute, right? Now my little turbine is connected to a motor at the end. If I then connect the wires very precisely to my propeller here, I should be able to connect it up similarly to how I did before. So when I get that turbine to spin, I'll be able to get my propeller to spin. Now let's think about this. Well, we don't want to be using water for this because water's going to get real messy real fast. I don't have any biofuels to burn. I could use geothermal power, which is taking the heat energy from the middle of the earth, the lava to burn it, but that requires digging a big hole, and that's going to be a whole other issue. So instead, why don't we use a little bit of wind? Now I've got a leaf blower here. If I can channel my leaf blower onto my turbine, I'll get the turbine to spin. As that turbine spins, the motor's going to get going. It's going to send my electrical energy all the way through my propeller, and hopefully we'll get that spinning. Let's give it a go. 3, 2, 1. Wow. Oh my God. It went so fast. But how cool was that? I was able to generate electricity using that wind energy. Crazy, right? Now let's just put that to the side because it's time for us to think and talk about the next great innovation. In fact, arguably one of the biggest innovations in human history was the development of the wheel, right? Now, the wheel allowed us to transport things long distance over lots of different terrain. But did you know that the wheel wasn't actually first invented for transport? Instead, it was faced this way and it was actually used as a pottery wheel. So people would spin it and they'd make really cool pots and clay devices to help us store grains and other useful items. Pretty cool, right? Then someone along the way figured if you turn it sideways and attached a cow or a cart or a horse to it, we were able to move it long distances as well. So we could take those grains and sell them in different towns. Now, using a wheel today, I want to explain another concept. I want to explain how gyroscopes work using angular momentum. It's a really, really big word, but it is lots of fun, right? Now, angular momentum is the idea that when you introduce a spinning concept or spinning motion into items, they kind of want to stay the same, right? So if I take my wheel right now and I just hold it this way, right now there are lots of forces at play. We've got a force called gravity, right? That's pulling the wheel down to the ground. If I let go of my wheel and just hold it with my string, which way is the wheel going to go? Is it going to fly up in the air or go down to the ground? Right? Let's find out, shall we? 3, 2, 1. Yeah, the wheel falls down to the ground, being held by my string due to gravity, right? But what happens if we introduce a little bit of angular momentum? Now for this, I'm going to need a volunteer. I'm going to need a friend from behind the camera to come up and spin my wheel. So who's coming up today? We've got Ken coming up. Ken from earlier. Now, Ken, you feel strong this morning? Or this afternoon? Yeah, excellent. Ken, what we're going to do is I'm going to hold the wheel. You're going to start spinning the wheel. We're going to introduce angular momentum, that spinning motion, and then I'm going to drop it again like we did before. You ready for this? All right, spin, 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 Ken. Let's go. Bust up. All right, there we are. We've got lots of spin here now. Now what's going to happen when I let it go? Oh, almost like magic, it stays upright as it's spinning. Eventually, though, as the spin runs out, it starts to fall back down, being pulled to the ground because of gravity, right? Now that's not magic at all. That's just a bit of science. Remember, angular momentum is the conservation of that spin. So as that wheel is spinning, it wants to stay spinning, wants to stay the same way. So while it's spinning, it's able to resist the pulling nature of gravity, staying upright. Crazy, right? Now, we use this concept, this idea all of the time. We actually use it to generate things like autopilot on planes, the GPS device on your phone that helps track you around, lots of really cool technologies. Now, thinking about autopilot and planes, right? That actually gives me my next innovation I want to talk about. I want to talk about planes. And have you ever wondered how a plane actually stays in the air, right? How it doesn't go crashing into the ground? That's because of another force, another concept called Bernoulli's force, which I'm going to demonstrate right now. So let's put this wheel away. And for this, we're going to need a hairdryer and some ping pong balls. Now, this is a really cool activity, something that you guys could actually do at home if you'd like. Like I said, all you need is these two things. Now, the Bernoulli's force is the concept that if you were to take a string of high, fast-moving air, that's like the air that's coming out of my hairdryer, right? You're going to actually get low pressure. So all of the air on the outside is going to be much higher force than the air coming through here. If I then get a ping pong ball and I balance that ping pong ball in the stream of my hairdryer, what do you think is going to happen? In fact, in the comments right now, if you have a prediction for me, why don't you write it down? I would say that there's a couple of things that could happen. Possibly my ping pong ball would fall down to the ground because of gravity. It could fly through the room because the hairdryer is pushing it out of the way. Or it could possibly hover in midair because of, well, let's find out, shall we? So we've got some people thinking it's going to fly. Some people think it's going to hover. Some people think it's going to float. All right, let's find out. So I'm going to turn on the hairdryer and then I'm going to place the ball in it. And there it is. It floats right up in the middle of the hairdryer. Now, this isn't magic at all. This is the Bernoulli's effect. So the hairdryer pushes it up. Eventually, gravity pulls it down until it hovers. Now, the other cool thing is that there is a fast moving air here, which causes low pressure. That means there's high pressure all the way around the hair dryer, meaning that the ping pong ball is actually getting stuck in the stream of air. So if I turn it back on again, and now I tilt the hair dryer. Look at that. It looks like almost like magic flying, being suspended because of that stream of air. Oh, so it falls back down. Now, this is such a cool concept. You can make the ball go left, you can make it go right. And you can do this at home, explaining to your friends and family how the Bernoulli's effect works using just a ping pong and a hairdryer, right? Pretty cool. Now, if you've ever seen a street science show, you know that we like to do things to the extreme. So while a hairdryer and a ping pong ball totally works for this, why don't we try this a little bit more extreme? Why don't we try doing this again using a beach ball, right? Now, my beach ball is a lot bigger than that ping pong ball. I don't think a hairdryer is going to cut it. So we're going to need to bring in a little backup. Let's bring back the leaf blower. Now, this time around, what we're going to try and do is create that stream of fast moving air above my beach ball, right? That's going to allow all the other air in the room to try and fill up that stream. And we're going to be able to generate lift underneath the ball, because hopefully we're going to get my ball to fly, right? So this doesn't always work. So let's try if I can get it balanced right. Got my ball up. I'm going to turn on my blower. Oh my God. Oh my God. Oh, there it goes. So almost like magic, that ball was flying through the air, being suspended because of the Bernoulli's effect. Crazy, right? Crazy. Now, I'm just going to put that leaf blower over for a moment, because that's a very important question here. Planes are really good at taking us long distance, right? But if I want to go a short distance over just land, I'm probably just going to use like a car or a bike, right? Well, what if I wanted to go over both land and water at the same time, right? Well, then I'm going to need a hovercraft. Now, a hovercraft is a device, sometimes it's called an air cushion vehicle, right? Which actually pushes air down into the ground to allow a vehicle to almost levitate as it moves around. And I totally have one of these devices. I've got one right here, right? So this device has a fan, which you can just see, spin it around. I've got a fan over here, right? Now, when I turn it on, the fan's going to push air downwards underneath the hole here from all of these holes underneath. You can start seeing them over here, right? And it's going to lift up, causing my whole hovercraft here to levitate. Now, this particular hovercraft has been custom made for my little puppy dog, Rufus. Do you want to meet him? Of course you do. This is little Rufus. Hi, Rufus. How you doing? Now, little Rufus here is only a little puppy. He's not very good at walking very well. So sometimes when I want to go long distance, instead of letting him walk in the lead, I make him sit on my little hovercraft here and we can pull him along. Now, while it's not hovering, it's actually really, really hard to pull Rufus along this hovercraft because my hovercraft is rubbing against the ground, causing lots and lots of friction, right? But if I turn my hovercraft on, we should be able to see my hovercraft almost float or fly almost across the stage. So, should we give it a go? So let's turn them on and turn on the fan. There we are. So the air tank was down. You've got it floating around suddenly. There we are. Vertical line flies across the hovercraft. Look how fast he goes. All right, on, Doc. Rufus is going so far. He's almost flying off the end of the table. I think we're definitely going to take this little hovercraft outside later. All right, Rufus, it's time for you to go back sitting outside the tables. Bye, Rufus. Bye. Now, all the talk about hovercrafts, right? It's kind of making me a little bit hungry. I think we should have a little bit of a snack break, right? But as we all know, before we bring out any food, something really important we need to do is to wash our hands. So let me bring out some soap so I can wash my hands real quick. Now, did you guys know that soap is actually another really, really good invention, right? Soap was actually developed a little while ago, but the guy who actually promoted the use of it was a scientist called Dr. Semmelweis, right? Now, Dr. Semmelweis was a physician, a doctor, who worked out that if people wash their hands thoroughly, fewer people died after having surgeries, after giving birth. Now, he predicted that that was because the soap was able to break down different bacteria, different microbes that we couldn't see with our eyes, but were making us sick. Now, back in the day, right, people didn't really believe in microbes. They thought he was crazy for thinking that such small items that we couldn't see could make us sick. So he was ridiculed. He was called crazy, and he was stuck in the loony bin, right? People put him to the side. When he got put into the loony bin, unfortunately, the guards thought he was crazy as well. They beat him up so badly, they ended up dying of infected wounds caused by the microbes that he was trying to prevent us from having in the first place. Now, these days, we know a lot better. We do know about bacteria. We do know about microbes. So we all know that when we want to eat anything, we need to wash our hands. Now, the way a lot of our soaps work is by creating those bubbles, and those bubbles can actually break open the outside layers of those bacteria, of those microbes, making them die, which makes us nice and healthy. But I don't know about you guys. I love bubbles. I think bubbles are like one of the best things about soapy water. And I think we should get some more bubbles with this soap. And to do that, I'm going to use a really, really cool material called liquid nitrogen. Now, before I handle liquid nitrogen, it is seriously cool. Negative 196 degrees, right? So it's so cold that before I take it out, I need to get some glasses. I need to find some safety gloves. Right? Because you don't want to touch liquid nitrogen with your bare hands because it's just way, way too cold. Now, because it is so cold, the moment I pour out my liquid nitrogen into anything, it's going to start to boil, turning from a liquid into a gas, right? And that gas is going to start to boil and make lots of really cool bubbles, which will be great for my hand washing. So I've got some liquid nitrogen right here. Going to open it up. I only have a very small amount left. Going to pour them in. Oh, no, to this one. I only have a very, very small amount left here, but that small amount is enough to be able to get some bubbles. Now, you should be able to see there's actually a bit of smoke or cloud forming here, right? That cloud or smoke is actually made up of water vapor close to my liquid nitrogen that's actually freezing instantly. Here we are. Now, if I funnel all of that smoke into my bubble mixture, I can get these beautiful, amazing bubbles. Whoa, let's do that again. And there we are. We can fill it up and let's go one more time before my nitrogen runs out of fuel. And oh, let's go again. All right, there we are. Got one last little bubbles on a little. And he is gone. Oh, beautiful. I can do this all day. It's magical. But we're not here to play bubbles. We're here to wash our hands. So let's pop them to the side. We might need to get some more nitrogen to play with later. Pop them to the side for a moment. And let's get back to my little bubble mixture. There we go. Yeah. Oh. All right, hands are all clean now. Let's eat. Now, I think my best snack that I've got here is some chips, right? And the chips, there we are, chippies. Now, I absolutely love chippies, right? Potato chips, delicious. But did you know that potato chips are also an innovation, right? You may notice that whenever you open up a new packet, they have a little snack. A little bit of gas or air inside those chips, right? Now, that gas actually has a really interesting purpose. Its purpose is to make sure those chips don't get smashed in transport, right? So we need enough gas in there to kind of stabilize the chips, hit the pressure, so that as we're moving through the environment, if we hit something, chips don't get broken, which no one wants broken chips, right? But of gas would be used inside of the chippy packets, right? Not really sure. I think we should do an experiment to find out. Because we can't just use any gas. Some gases are going to be really, really good for this. Some gases, though, might not be so good for transport. Because remember, when we transport things, we're going to be driving around in cars or buses, right? What happens if on the highway there is a massive crash and that bus or that car goes on fire with my chippies in the back? We don't want to use a gas that explodes, do we? So let's do an experiment. Now, I'm going to put my chippies to the side and I'm going to grab out some balloons. The first balloon we're going to use is this guy here, right? Now, this balloon is full of my breath. So that's made up of oxygen and carbon dioxide. And I can see in the comments here, some people are predicting that carbon dioxide might be the gas that we use in our chippy packets. Now, right now, it looks like a good gas. It's going to fill up my balloon, it's going to fill up my chip packets. But what happens if it's in a car accident? Let's find out. So we can't actually drive a car into the balloon, right? That's not going to be silly. So instead, let's use flamethrower, right? If I attach a bit of gas to my flamethrower and turn it on, we're going to simulate a car crash using the fire. Now, what do you think is going to happen to the balloon? Is it going to pop with a giant fiery explosion? Or do you think it might just pop with a loud noise, all right? Let me know in the comments, what do you think? We see some people saying pop, some people saying fiery explosion. There's only one way to find out, right? So, glasses on. Let's turn on the fire. There it is. Now, this could potentially get loud. If you do not like loud noises, you might want to cover your ears here. In 5, 4, 3, 2, 1. Oh, well, that was a bit anticlimactic. It did pop, it made a big noise, but there was definitely no fire, all right? So this gas would be safe to put into the chippy packets in a car crash. But we probably don't want to use this gas, because remember, this one was full of carbon dioxide and oxygen from my breath, right? Now, oxygen is a really, really reactive gas, and that can actually cause our chips to go stale as the oxygen comes into contact with the potato. And I don't know about you guys, but I definitely do not want stale potato chips. So we're not going to use oxygen, we're not going to use carbon dioxide, but it's not going to be for me. So let's think about this. We need a gas that's relatively easy to get, right? And the most abundant gas in our universe is a gas called hydrogen. It's actually the smallest gas, and we use it for things like powering our sun. So maybe hydrogen gas might be a better gas for us to use. So let's reset. We're going to put this to the side. We're going to get a hydrogen balloon out right now. Now, hydrogen is a very small gas, very light gas, which means it does float, just like this balloon is doing right now. It's floating away. Oh my gosh, there we are. But do we think my floating balloon is going to pop in a fiery explosion or just make a loud noise? While I eat this chippy, I'm going to get you guys to answer that in the little chat. What do you think? Is it going to pop? Is it going to explode? Not quite. All right. We're getting loud pops. The balloon is going to make a big noise. No fire. All right. Not going to do anything, some people say. Well, let's find out, shall we? All right. Got my balloon ready. In case it does make a fiery explosion, we're going to go safety glasses, and to simulate my car crash, we have the flamethrower again. Let's bring it out. The fire. All right, guys, in case it's a bit loud, cover your ears. In 5, 4, 3, 2, 1. Whoa! Whoa, whoa, whoa. Giant. Man, I wish you guys were here. You would have been able to feel the heat that came off that one. I don't think that would have been the same thing to have in the back of the car, right? If we had a car crash, all of my chippies would have exploded, and I wouldn't have beautiful original flavor. I'd be left with smoky barbecue. It wouldn't be fun at all. So we can't use hydrogen, it's far too reactive. We're going to use something else. Now, in our atmosphere, the gas that we breathe, right? A lot of it is oxygen, some of it is carbon dioxide, but the most reactive, the most abundant gas in our atmosphere is actually a gas called nitrogen, right? And over here, I actually have a nitrogen balloon. So a balloon full of nitrogen gas, right? What do you think is going to happen if I take this balloon and we pop this one into a car crash, right? Okay, last time, pop it into the comments for me. Do you think this balloon, this nitrogen gas balloon, is going to pop with a loud noise, or is it going to explode with a fiery crash, right? Let's have a look. Some of us think fireball. Some of us think it's just going to pop. Some of us think it's still not going to do anything, of course. All right, lots of loud noises this time, all right? Now, I've got my balloon. Safe it's still in my head. Let's do this one more time, shall we? Fire. Oh, here it is. We need that flamethrower to stimulate our car crash. So, got my balloon ready. Get the fire. There it is. And again, don't like loud noises, you might want to cover your ears. In 5, 4, 3, 2, 1. Oh, well, that was a bit anticlimactic. Nothing happened. So it looks like nitrogen gas is probably the winner here. It is a completely safe gas. It's not gonna pop in a fiery explosion, which is actually a really good thing. Because imagine if nitrogen gas was explosive. It is the most abundant gas in our atmosphere. We would have fireballs going off all over the place, right? Nitrogen is actually an inert gas, which means it doesn't really react with anything. It's completely safe for us. It's really boring, actually, which means it's actually completely safe for our chippy packets. And we actually do use nitrogen gas to make our chips, right? To keep them nice and safe. But how do we actually get that nitrogen gas into our chippy packets, right? Well, what we do is use our liquid nitrogen, the same material I had earlier. So let's do this. I've already opened my chips, so I need to repackage them so I make them for later. So let's put this to the side and try and make my chippies come to be nice and healthy. So I've got my chips. For this, I'm going to need a bag. Let's use a clear bag today. We're going to need some nitrogen, which means I'm going to need some gloves again. Safety glasses, of course, because nitrogen is a really, really, really cold material. And last but not least, we need our nitrogen. Beautiful stuff. Now, you can might be able to see on the side of my flask here, that nitrogen is so cold, it's actually been able to solidify or crystallize around the side here. That's actually snow forming, which is pretty amazing. Now, nitrogen, as it boils, turning from a liquid to a gas, will actually expand in size 694 times, which means to fill up a bag this size, you don't really need a whole lot of it at all. You probably need about 5 mils. Now, I have a tiny beaker here. This is a 100 ml beaker. I need like a fifth of that, if that. So let's get some nitrogen. Now let's pour just a really tiny amount into my flask. Really tiny beaker, so cute, so cute. Now you might be able to see that liquid boiling away inside that flask, doing its thing, looking pretty. Now inside my bag here, let's take off my gloves for a second so I can actually use this. We want to put our chips inside. We'll keep them nice and safe. Now, while my chips are just here, they're now exposed to the oxygen and everything around. So they're not going to be very fresh for today. But if I displace that oxygen using that nitrogen, I'll be able to have nice fresh chips that would keep theoretically forever, right? So let's get my gloves back on. Like I said, I need an itty bitty tiny amount, just about 5 mils. We're going to pour that in. Here we are. Seal it up nice and quick, letting that nitrogen boil off, displacing all that oxygen. And there you have it. As that nitrogen boils away, it fills up that bag with the gas. And now my chips are nice and fresh again. Now I need a way of remembering what exactly I've done to these chips. And to do that, we're going to turn up my marketing department. And I've got these cute little stickers that I've got here, which means that if I pop a sticker on, I will remember that these chips aren't just regular chips. These seriously cool chips. Delicious snack for later. All right, let's clean up my snacks. Snacks. Junior scientists, unfortunately, I've used a lot of time up here today. It is almost time for me to finish my show for today. I hope you guys have been having fun, but we are leaving the best for last, right? Now, we haven't even begun to talk about probably one of the most innovative ideas, the innovative concepts that you guys are going to have to deal with in the future. We're talking about AI, artificial intelligence. Now, artificial intelligence has come to be because us scientists, we're pretty smart people. We keep putting lots and lots of different data, different information out into the world, so much so that even the smartest people in the universe, we just can't comprehend all of that information. There's far too much of it. Now, we could spend hundreds and hundreds of years manually going through it, but we were able to develop a program, a way of sifting through data to make some really useful conclusions. That is our artificial intelligence. Now, we use artificial intelligence all the time. If you have a smartphone at home, you've probably used artificial intelligence in a way of search functions for Google. If you've ever used Google Maps or another mapping program, you've probably used it to help you find the best way to get maybe your snacks or maybe to get to your school in the morning or even on holiday going to the airport, right? We use it all of the time. And in fact, we can use artificial intelligence to help us make music as well, right? Now, because we are celebrating National Science Week, I've done exactly that, right? I've taken an artificial intelligence generator, an AI machine, and I've given it some prompts. I've given it National Science Week. I've given it Virtual Excursions Australia and Street Science, and I'm going to see what kind of song it comes up with. But because it is in National Science Week, instead of just playing that song to you, I thought I would show it to you using a really cool technique. So let's clear my table again. We're going to bring out this guy. Now, this here is a special tube called a Rubens tube, right? It's actually a tube, a chamber here, that has lots and lots of little holes in it. Now, if I take that chamber and I attach it to a little bit of gas here, I will fill up my chamber with a bit of gas, right? Now, there is a speaker attached to the other end of my Rubens tube, and that speaker is going to play some music. Now, I don't know if you guys know about sound, but the way sound works is that it actually is vibrations in the air around us. So if I fill up my tube with gas and I attach my speaker to the gas, right? When I turn my speaker on, my speaker is going to push and pull against all of those gas molecules, causing the gas to move. Now, if I light that gas on fire, we'll get a bit of fire. And that fire will respond to the movement of the gas, causing a little bit of a dancing effect to that music. Now, it's quite a big chamber, so we've got to really fill it up before it will ignite. Give it a moment. Turn up the gas a little bit. We might turn down the lights as well to make it a bit easier to see that it's lit. I think it's lit now. Seeing a bit of fire. Am I seeing a bit of fire? Yes, got a bit of fire there. There it is. All right, so you should be able to see a nice steady flame here. Nothing much happening just yet. You're just getting a little bit of fire, right? Now, this speaker is attached to my phone over here. So it's gonna. There it is, back. Speaker's attached to my phone. When I press my button here, we're going to hear the song that AI generator has come up with. So, like I said, I put the prompts in. I put National Science Week. I put in Virtual Excursions Australia, and I put Street Science. Let's see what's happened. Give it a play. I mean, we got a little bit of dancing. I'll just do that again so you can hear the whole song through it. That goes for 30 seconds. We're definitely getting a little bit of dancing, but I think we can do better than that as well. So let me quickly go through my phone. Let me find a much better song, a much more, song that's got a bit more oomph to it. And let's see if we can really see this moving. Yeah, here we are. Oh, beautiful, guys. You can see it fully dancing over the side. Oh man, I wish you could do this. I wish we could do this all day, but unfortunately we do have to finish the show somewhere. So I'm gonna have to cut that music off. We're gonna have to turn off the gas. Oh, what an epic way to finish our show. This is unfortunately the end of our show today. I hope you guys have had fun. Hope you guys have learned something, but most importantly, I hope I've inspired you guys to look at the world we live in a little bit differently. It's going to be you guys, the new innovators, the new scientists of the future that come up with new innovative ways to live the way we do. It might be you that comes up with the next cool AI generated sound machine. It might be you that comes up with the next innovative snack, the next hovercraft. The world is the limit, really. Hope you guys have had fun. If you have any questions or comments, please put them into the chat right now. We'll see if we can answer them real quick. Otherwise, enjoy the rest of your day. Happy National Science Week, guys. I look forward to seeing what you guys come up with. Bye.
Thank you so much for that, Dr. Shazza. We've got some thank yous, but yeah, if you want to pop in the Q&A, we've got a time for a couple of questions if you have something to ask. Otherwise, we will be sharing a copy of the recording for those of you that have joined us if you want to watch some of those experiments again. We've got half a question there. What is your... Do you have any other ideas on what you can make at home?
Oh, so many ideas, so many ideas. There's so many really cool experiments you can do. You can do things like underwater fireworks. You can do things like lava lamps. In fact, if you want some ideas, if you jump onto the Street Science website, we've got heaps of at-home activities that you can try. Streetscience.com.au, I think we are. Jump on board. My particular favorite is the underwater fireworks. I think they're magical, and all you need is oil, water, and a bit of food dye. Easy to get.
That sounds great. And we will share that link on our follow-up as well. Someone's asking from Kangaroo Island, has one of your experiments ever gone wrong? He's asking if there's ever been an explosion.
Oh, unfortunately, sometimes in science, things do go wrong. But remember, you never give up. I have done a couple of science experiments where something might have tipped over and set a bit of fire on something on fire. I've never had a school explode yet. Fingers crossed not, but we have had a bit of fire. But it's really easy to get rid of fire because in order for a fire to establish, you need three things: oxygen, fuel, and heat energy, right? If you can smother the fire, you get rid of the oxygen. If you can cool it down, you can get rid of the heat. And well, that's all you really need to do most of the time. So it's never been an issue. Good question though.
Excellent. We also had a question about what was one of the first experiments you ever did, and do you have a favorite?
Ooh, okay. That's a really good question. This now really depends on what you define as your first experiment, I think. I think probably one of the first experiments I did that ever got me really interested in science was extracting DNA out of things. I think I extracted DNA out of strawberry once when I was at school, which was pretty epic. One of my first experiments here at Street Science was actually making clouds out of liquid nitrogen, which I thought was magical and beautiful. And I've been doing this for years and years and I can't get enough of it. So fantastic.
Do you have a favorite?
Well, I'm going to say liquid nitrogen clouds. You can do so many cool things with them. You can make really, really big clouds, really, really small clouds, bubbles with clouds. Like, clouds are the best. Love clouds.
Excellent. We've got some Joseph School at Peak Hill. Does air absorb gravity?
Ooh, very smart questions here. Well, Gravity is a force or a field, really. So air can't absorb it per se. Gravity is the idea that the Earth's surface can actually pull down against it. So you drop something, it falls down to the ground because of gravity. Now, there's air in our atmosphere at all time, and that air is actually being pulled down because of gravity as well. If you got rid of the air, you'd still have gravity affecting it. So air itself doesn't really absorb gravity, it doesn't really interfere with it, it just kind of gets pulled down because of gravity as well. Does that answer your question, St. Joseph's?
I think so. And then we had, we've got the favorite experiment already. I saw another one pop up, but that might be it. Lots of exciting things about experiments. So I will absolutely share all of those amazing street science absorb ones. And I thought I saw one pop up about who do you work with, who's in the street science team?
Oh, we've got so many people in the street science team. We've got Ken that you met earlier. I've got my friend Taz, who is a ranger. She used to work on Fraser Island. We've got, Science Steve, who you may have met. He used to be a teacher. Danny, who's worked with lots of animals in Africa before as well. We've got heaps of really cool scientists that work at street science who travel around Australia, Queensland in particular. We do lots of cool experiments for kids just like you guys.
And excellent. Someone's asking how many experiments have you done? I would say thousands.
Hundreds, thousands of experiments. We do them every single day. So I think more than I could count.
Well, it sounds like we've got some amazing budding scientists with us as well, and hopefully they can do some of those experiments for the rest of National Science Week and beyond. Just because it's not National Science Week doesn't mean you can't do more science. So thank you so much from the whole team of Street Science for joining us today for SciFest. It was a fabulous way to finish off our program this week, and I look forward to seeing you all again soon. So thank you, everyone.
Happy National Science Week, everyone. See ya.
This National Science Week project is supported by the Australian Government and brought to you by Virtual Excursions Australia.